Any sufficiently advanced technology is indistinguishable from magic. Arthur C. Clarke said that. And, it feels really relevant today, especially when we look at huge challenges like climate change.
Absolutely. The search for solutions is really pushing boundaries, isn't it?
It is. We're seeing the usual methods scaled up, sure, but also these really radical ideas popping up.
Ideas that sound like they're straight out of science fiction sometimes.
Yeah, exactly. And the pressure of the climate crisis seems to be driving that exploration.
It really does.
Huh.
Which brings us to today's topic.
Right. So today we're doing a deep dive into something pretty extraordinary. You've brought us an excerpt from a First Post article. It talks about a paper on Archif proposing a nuclear detonation as a climate fix.
A massive one. It's the kind of proposal that just stops you in your tracks.
Definitely. So our mission here is to unpack what this source material tells us. Look at the details, the reasoning behind it, the risks, the claims.
Let's lay it all out based on what's in the article and the paper it discusses.
And this is potentially really relevant if you're keeping up with current affairs. Maybe you're studying for exams like the UPSC, where understanding the whole spectrum of ideas, even the wild ones, is important.
Or maybe you're just curious about the, let's say, cutting edge or perhaps controversial edge of tackling global problems.
So let's start with the source of this idea. Who came up with it?
Well, this is interesting in itself.
Mm-hmm.
The paper's author is Andy Haverly. The article describes him as a 25-year-old software engineer.
Okay, so not a climate scientist or a nuclear physicist.
No, the source specifically mentions he doesn't have a formal background in either field. And the paper was published on Archif.
Archif, so an open access platform, often for preprints, maybe not fully peer-reviewed in the traditional sense.
Exactly. So the idea isn't coming from, say, a major university climate research department or a national lab.
Got it. Okay, let's get to the core proposal then. What exactly is he suggesting?
Fundamentally, the plan is this. Bury a huge nuclear device very deep under the ocean floor and detonate it.
Wow, okay. And the goal isn't destruction.
No, not in the typical sense.
Yeah.
The stated goal is carbon capture on a massive scale.
Carbon capture via nuclear explosion.
It leverages a natural process called enhanced rock weathering, ERW.
Right, I've heard of that, where certain rocks, like basalt, slowly react with CO2 and lock it away.
Exactly. Basalt is key here. But that natural process takes geological time, millennia.
Too slow to help us now.
Way too slow. So the nuclear blast acts as the enhancement, a very powerful one.
How does that work?
The explosion's energy would pulverize a massive amount of this basalt rock on the seafloor.
Like grinding it up.
Precisely.
Mm-hmm.
Creating a huge increase in the rock's surface area. More surface area means much faster chemical reactions with the surrounding environment, pulling CO2 out of the water and ultimately the atmosphere to bind with the minerals.
So it's using a bomb as a giant underwater rock grinder to turbocharge a natural process.
That's the core concept, yeah.
Okay, the specifics. This is where it gets a bit staggering, right? What size device are we talking about?
This is where the numbers become almost unbelievable. The paper proposes a yield of 81 gigatons.
81 gigatons. Wait, the Tsar Bomba, the biggest ever tested, was what, 50 megatons?
Exactly, 50 megatons. This is 81 gigatons. A gigaton is 1,000 megatons.
So it's more than 1,600 times bigger than the Tsar Bomba.
That's what the source says, yeah. Over 1,600 times the explosive force. Just try to picture that.
Where?
It's beyond anything we've ever actually done.
Mind-boggling doesn't even cover it. Where would you even contemplate doing something like this?
The proposed location is the Kerguelen Plateau.
Kerguelen, in the Southern Ocean.
That's the one. Described as remote, vast, and importantly, rich in basalt rock. It's an underwater volcanic plateau.
Okay, remote makes sense. And you said buried deep. How deep?
Very deep. The plan requires burying it 3 to 5 kilometers into the basalt seabed itself.
3 to 5 kilometers of rock penetration.
Yes. And remember, the seabed there is already under 6 to 8 kilometers of ocean water.
So total depth, 9 to 13 kilometers below the sea surface, deep inside solid rock.
That's the proposal. And that extreme depth is crucial for their containment idea.
Containment? For an 81 gigaton blast?
Well, the theory is that the sheer weight of all that rock and water, the pressure down there, it's immense, up to 800 atmospheres would act as a natural buffer.
To keep the explosion localized.
That's the hope. To contain the blast energy and the immediate effects underground and underwater. The paper actually has a quote on this.
What does it say?
It says, by burying the nuclear device kilometers underground, under kilometers of water, we can be certain that the explosion will first pulverize the rock, then be contained by the water.
Certain. That's a strong word for something unprecedented.
It is. It underlines a core assumption of the whole plan.
Okay, let's connect this back to the CO2 goal. How much are they aiming to capture?
Right, the calculations. They start with an assumption, based on existing literature apparently, that global CO2 emissions are roughly 36 gigatons per year.
Okay, standard figure. And the target?
The goal set out in the paper is to sequester 30 years' worth of those emissions.
30 years. So 30 times 36. That's over 1 trillion tons of CO2.
About 1.08 trillion tons, yeah. A massive amount.
And how much basalt needs to be pulverized to soak up that much CO2?
The calculation, again based on standard ERW models they cite, estimates about 3.86 trillion tons of basalt.
3.86 trillion tons of rock. That's hard to visualize.
It really is, and this connects directly back to the bomb size.
How so?
They calculate the energy needed to pulverize that much basalt. It comes out to roughly 3.05 times 10 to the power of 20 joules.
Okay.
And that amount of energy is what an 81 gigaton explosion would theoretically release.
So the bomb yield is calculated specifically to match the energy needed for the rock pulverization required for the CO2 target.
Exactly. It's all linked in their model. They also assume about 90% efficiency in the explosion's energy actually going into pulverizing the rock based on some previous modeling of nuclear impacts.
This whole idea of using nukes for, like, civil engineering, it sounds familiar. Didn't the U.S. try something like this decades ago?
You're thinking of Project Plowshare.
Plowshare, right. What was that about again?
It ran from the late 50s to the mid-70s. The U.S. government explored using nuclear explosions for peaceful purposes, digging canals, creating harbors, mining, that sort of thing.
Was it successful? I seem to remember issues.
Well, there were tests. The Sedan test in '62 is probably the most famous.
Yeah.
It created a huge crater over 300 meters wide.
What?
But it also kicked up a lot of radioactive fallout that spread across several states. That was a major problem.
Yeah, I can imagine. So Plowshare was eventually shut down.
It was. Concerns about the environmental contamination, public opposition, and frankly, limited practical success led to its end.
So this new proposal, it sort of echoes Plowshare's ambition using that raw power, but for a totally different goal.
Precisely. Plowshare was about excavation, moving earth. This is about pulverizing rock in place to accelerate a chemical reaction for carbon capture. Same kind of force, different application.
Okay, even buried deep, 81 gigatons. The safety concerns must be astronomical. What does this study actually say about the risks?
This is where it gets maybe controversially optimistic. The study suggests that despite the insane scale, the risk to human life and global ecosystems is manageable, even minimal in some ways.
Manageable, minimal, for something 1,600 times our bomba. Seriously.
I know, it sounds jarring. The paper is quoted claiming few or no loss of life due to the immediate effects of radiation.
Immediate effects, okay. But long-term, fallout.
Well, it does include a caveat. It acknowledges the project will impact people and cause losses, which seems to refer to longer-term consequences or maybe localized effects.
So what about fallout, the thing that doomed Plowshare?
Haverly apparently downplays this risk significantly. The source quotes him saying the increase in background radiation would be just a drop in the ocean.
A drop in the ocean? Compared to what?
He apparently compares it to annual radiation from coal power plants and also points to the total radiation released from all the historical nuclear tests, over 2,000 of them.
So the argument is, we've already put radiation out there, this won't add that much relatively speaking.
That seems to be the implication. It's definitely a specific perspective on risk assessment.
Are there any proposed technical measures to limit the radiation?
Yeah, the paper suggests using a standard fission-fusion type bomb, a hydrogen bomb, but optimized somehow to produce fewer persistent radioactive isotopes.
Optimized for cleanliness, relatively speaking.
Kind of. Plus, they're relying heavily on the kilometers of surrounding basalt rock to physically trap most of the radiation deep underground.
The geology as a shield again. But does the study admit any significant local damage?
Oh, yes. It explicitly states that the immediate blast zone, a section of the seabed, would become uninhabitable for decades.
Uninhabitable for decades? Okay, that's not minor. How big an area are we talking?
The study estimates this severely impacted zone would be restricted to maybe a few dozen square kilometers.
A few dozen square kilometers rendered useless for decades.
Yes. And the argument presented is basically a trade-off.
The trade-off being this localized destruction versus global climate catastrophe.
That's exactly how it's framed in the source material. sacrificing a small patch of remote deep seabed to potentially avoid the far larger, widespread devastation projected from unchecked climate change by 2100.
And those projected impacts are the usual terrifying list. Rising temperatures, weird weather, ocean acidification.
All of that. Altered rainfall, biodiversity loss, food insecurity. The whole suite of predicted consequences. The argument is the sheer scale of that potential future justifies considering even something this radical.
It puts it in context, I suppose. And this isn't the only controversial geoengineering idea floating around, is it?
Not at all. It's important to see this as part of a wider, sometimes uncomfortable conversation about large-scale interventions.
What else?
Well, the source mentions things like stratospheric aerosol injection, basically spraying stuff high up to dim the sun, or marine cloud brightening.
Trying to reflect sunlight back into space?
Exactly. Those are aimed at temporary cooling. The UK's ARIA research agency is apparently funding experiments looking into these. Haverly's nuclear plant is mechanically very different, obviously, but it shares that same characteristic. A high-tech, potentially high-risk approach to a massive problem.
Okay, let's talk economics. Because the paper apparently makes a bold claim about cost-effectiveness, too.
It does. The estimated cost for the nuclear device itself, designing, building, deploying it, is put at around $10 billion.
$10 billion? That's a lot of money.
It is. But the comparison point they use is the projected cost of climate change damage.
Which is?
Estimates cited from groups like the IPCC or economists like Nicholas Stern suggest climate damages could exceed $100 trillion by 2100.
Okay, $10 billion investment versus potentially $100 trillion in avoided damages.
That's the calculation presented, which leads them to claim, wait for it, a 10,000x return on investment.
10,000 times return. Wow. If it works and doesn't cause some other disaster.
Right. That's the massive if. But based purely on those numbers, the economic argument is framed as incredibly strong, high value, if it could be done safely and effectively in time.
What kind of timeline do they even suggest for something like this?
Believe it or not, the paper suggests deployment could potentially happen within a decade.
A decade? For designing, testing, building an 81 gigaton bomb, drilling kilometers into the seabed, and getting global agreement. That sounds optimistic.
Extremely optimistic, you'd have to say. It depends on clearing enormous hurdles, technical, political, international relations.
Yeah, understatement of the year. What are the absolutely crucial assumptions this whole thing relies on, the things that must be true for it to even be remotely viable?
The paper lays out a few critical ones. First, obviously, that setting off an 81 gigaton explosion deep underground won't trigger some global catastrophe, like a mega earthquake or tsunami or some unforeseen atmospheric effect.
A rather large assumption. What else?
Second, that a device this big, even if designed for pulverization, wouldn't be seen as a weapon or destabilize global security. That it's genuinely too big or impractical for military use.
Another huge geopolitical if.
Third, it assumes that our current climate trajectory continues, that we don't achieve major decarbonization breakthroughs soon, that would make such a drastic intervention unnecessary.
So it assumes the worst-case emissions path continues.
Seems to be the basis, yeah. And finally, the core technical assumption, that the explosion will actually sequester the target amount, 30 years worth of CO2. That the pulverization works as modeled, the chemical reactions happen as expected, and the carbon stays locked away.
So many things have to go perfectly right. Does the author acknowledge the risks?
Yes, to be fair, the source includes Haverly's concluding remark. This is not to be taken lightly. It acknowledges both the potential upsides and the very real dangers.
It's not presented as a magic bullet, then.
No, more like a high-stakes, scientifically structured gamble based on their calculations. The study concludes by framing it as a radical strategy, yes, but one where they've tried to define the parameters needed to make it work while minimizing side effects, at least in theory.
It really is just wild to think about an 81 gigaton nuclear blast under the sea as a climate tool.
It forces you to confront just how desperate the search for solutions might become, doesn't it? What kind of risks seem potentially acceptable when faced with existential threat projections?
Yeah. And it raises huge ethical questions about intervening in Earth systems on such a massive scale with consequences we probably can't fully predict.
Absolutely. Who decides? Who bears the localized risk? What if it goes wrong?
For anyone listening, especially if you're tracking complex global issues, maybe for UPSC, prep, or similar, this is a fascinating, if alarming, example of the kind of thinking emerging at the fringes. It shows the pressure points.
It definitely throws the scale of the challenge and the potential extremity of proposed solutions into sharp relief. What part of this whole proposal stands out most to you?
For me, honestly, it's that 10,000x return on investment calculation. It's chilling in a way. It suggests the perceived cost of climate inaction is so colossal that even this almost unthinkable act can be framed as economically rational on paper.
That economic framing definitely shifts the perspective, doesn't it?
Really does. Well, if you found this deep dive into a truly radical idea interesting, or maybe just thought-provoking, please do like and subscribe to the show. It really helps us continue exploring these complex topics.
And please leave a comment. We'd love to hear your thoughts or any questions you might have about this or other geoengineering ideas you've come across.
Just to reiterate, this discussion was based on details reported in a first post article about Andy Haverly's paper published on Artstoiv.
It certainly makes you think about the old saying, desperate times call for desperate measures. The question is, how desperate are we, and what measures become thinkable?